Hi, today in this video we are going to see about interference and system capacity. So it is a major limiting factor in the performance of cellular radio system. It creates bottleneck in increasing capacity. Crosstalk is the interference in voice channels and missed or blocked calls is the interference in control channels. Urban areas usually have more interference because of greater RF noise floor and more number of mobiles. The sources of interference are another mobile in the same cell, a call in progress in the neighbor cell, other base stations operating in the same frequency band, and non-cellular system leaks energy into the cellular frequency band. The two major cellular interferences are co-channel interference and adjacent channel interference. In this co-channel interference, the frequency reuse, there are several cells that use the same frequencies. The cells that use the same set of frequencies are called co-channel cells. The interference between signals from these cells is called co-channel interference. It cannot be controlled by increasing RF power. Rather, this will increase co-channel interference. To reduce this co-channel interference, the co-channel cells must be separated by a minimum distance. When the size of the cell is approximately same, co-channel interference is independent of the transmitted power. Co-channel interference is a function of radius r of the cell and distance d to the center of the nearest co-channel cell. Increasing ratio of d by r, the interference is reduced, where d by r equal to q and q is called the co-channel reuse ratio. The yellow cells use the same set of frequency channels and hence interference with each other. In the cellular system, there are 6 first layer co-channels. For a hexagonal geometry, q equal to d by r, which is equal to root of 3n. A small value of q provides large capacity and a large value of q improves the transmission quality, smaller level of co-channel interference. A trade-off must be made between these 2 points. Let I0 be the number of co-channel interfering channels. The signal to interference ratio for a mobile receiver can be expressed as this equation. N is the path loss exponent which ranges between 2 and 4. The average received power at a distance d from the transmitting antenna is approximated by the equation given in this slide. When the transmission power of each base station is equal, SIR for a small mobile can be approximated as this equation given in this slide. For example, an AMPS requires that SIR be greater than 18 dB and N should be at least 6.49 for N equal to 4, that is minimum cluster size is 7. Co-channel interference. For hexagonal geometry with 7 cell cluster, with the mobile unit being at the cell boundary, the signal to interference ratio for the worst case can be given as in this equation. Activity. Adjacent channel interference. Adjacent channel interference is the interference from the adjacent in frequency to the desired signal. Imperfect receiver filters allow nearby frequencies to leak into the passband. Performance degrade seriously due to near-far effect. Adjacent channel interference can be minimized through careful filtering and channel assignment. Keep the frequency separation between each channel in a given cell as large as possible. A channel separation greater than 6 is needed to bring the adjacent channel interference to an acceptable level. Problem is severe if the user of the adjacent channel is in close proximity, that is near-far effect. The other transmitter captures the receiver of the subscriber. Also, when a mobile station close to the base station transmits on a channel close to the one being used by a weaker mobile, the BS faces difficulty in discriminating the desired mobile user from the bleed over of the adjacent channel mobile. The near-far effect is shown in this figure. The mobile receiver is captured by the unintended unknown transmitter instead of the desired base station. Near-far effect for case 2. In this, the base station faces difficulty in recognizing the actual mobile user when the adjacent channel bleed over is too high. Minimization of adjacent co-channel interference is by means of careful filtering and better channel assignment strategy. Channel in a cell need not be adjacent. For channel within a cell, keep frequency separation as large as possible. Sequentially assigning cells for the successive frequency channels. Also, secondary level of interference can be reduced by not assigning adjacent channels to neighboring cells. For tolerable ACI, we either need to increase the frequency separation or reduce the passband bandwidth. Power control for reducing interference. In this, ensure each mobile transmits the smallest power necessary to maintain a good quality link on the reverse channel. Long battery life, increase SIR and solve the near far problem effect will give power control for reducing interference. Assessment question. Thank you.